Hey everyone, now I want to go through um, the process of dimensional analysis when we're using the SI system. So I need to talk about the SI system prefixes and this stair step that you can find on your reference folder. Again, you don't have to memorize this. You shouldn't memorize it. This is attached to your assignment today. So I kind of just want to walk through some of the different steps here. On the left side, we can see the prefixes that are associated to the SI system. We can also see here in the center where base is listed. We've already talked about a lot of base units. For volume, a base unit would be liter. For mass, a base unit would be gram. For length, the base unit would be meter. Okay, and then we could have Celsius and we can have seconds as well if we're talking temperature and time, but those are the main ones that we're going to be looking at for our base units, okay? And again, you can see base is listed at the center of our stair step over here too, so just be aware of that. And then anytime we move up or down from the stair step, from our base units or any unit really, if we're going up the prefix system, that means it's 10 times the original amount you started with. So if we started with grams and we moved to decagrams, we now have 10 times the size. If we go to hectograms, that means we're now working with 100 times the size of a gram. If we go to kilo, that's 1,000 times the size of a gram from our base unit, okay? And then if you go down the stair step or go down our prefix system, we're actually dividing. So deci is 1/10 of the size of a gram. Centi is 100th of the size of a gram, and milli is 1,000th of the size of a gram. Kind of their prefixes lead to some of our monetary values as well. So just kind of wanted to go through that basic part with you and then do a couple practice problems and apply them to what we had done. So the first one I'm going to do with you is kind of a basic one of starting with, I'll just write it out. Convert 320 meters to centimeters. Okay. So for that, and all of these, if we're just working with SI systems, so I'm going to highlight this. I know I'm working with meters, and that same base unit of meter is present there. My prefix is centi. So I know I'm going to be working with my SI system. So for these, I only need to do single step dimensional analysis. What goes in the top left corner? My given measurement from the problem. Right, so I'm going to start with 320 meters. And what do I put underneath it? A 1 so that I have a fraction. What unit goes in the bottom or the denominator? What unit? Meters, because that's the same one as I had in the numerator. What unit goes in the numerator of my next window pane here? Centimeters, because that's my final unit I'm trying to get to, right? Now I need to figure out what values am I going to plug in for my conversion factor here. When I'm working through this, I'm going to use my stair step in my prefix list, and I'm going to identify which unit is larger or higher up on our prefix scale for the SI system. So is centimeters or meters higher up on my SI system scale? So centi is here, and meters is my base unit here. Okay, so my base unit of meters is higher up on the scale than centi. So that's going to be my larger unit in this case. The larger unit is always going to get a 1 next to it. Okay, so I'm going to put a 1 next to my meter. My smaller unit, according to my SI system scale, is going to have a 1 with several zeros behind it. And then it's going to be my job to figure out how many steps away we are from each other, and that will tell me how many zeros I'm adding. So again, here's my base with my meter. This is what I'm getting to. I'm starting with meters, so I'm 2 steps away from centi. So that means I'm going to add 1, 2 zeros behind my 1. So I'm going to put 100 centimeters as my conversion factor. Easy as that, right? Then to solve, again, I'm going to cancel out my meters. Those are gone. And I'm going to just multiply 320 times 100. And my final answer should look like this. 32,000 centimeters are in 320 meters. That's my final answer. Not too difficult, okay? I'm going to just kind of scroll up a little bit, not too far out of sight, and do another problem with you. If I have, let's see, 210 milligrams, I'm going to convert that to grams, okay? I'm going to erase some of this.
How do you pay $1?
Okay. Gonna work through that part. All right, at any rate, this time we're working through milligrams and grams. So my milli is here, and again, my gram is my base unit. So I'm gonna highlight that on both of them so we're on the same page. This time we're starting with milligrams though. I'm gonna just put my dimensional analysis over here while I avoid that other piece. Okay, and my setup is the same. What goes in the top left corner? My given measurement from the problem. So I'm starting with my 210 milligrams. I'm including my unit. What goes underneath it? A 1. So it's in fraction form. What unit goes in the denominator of my next window? Milligrams. Why? Because it's the same as the one that I was starting with, so I can cancel it. What goes in the numerator for my unit? Grams. Why? Because that's my final unit I'm trying to solve for. Now I need to figure out how many steps away am I and which unit is larger so that I can fill out the conversion factor and finalize my problem. So my question is, are grams or milligrams larger on my SI system scale? The correct answer would be grams. Why? Because it's a base unit, as we can see right here. Grams is my base unit. So this is the larger one. The larger one gets a 1 next to it. The smaller one gets a 1 with a certain amount of zeros behind it. And for that, we have to figure out how many steps away we are. And those steps tell us how many zeros to add. So I'm 1, 2, 3 steps away. So that means I'm adding 1, 2, 3 zeros to my milligrams. So that's my conversion factor. I'll end up canceling my milligrams out. And when I solve this, I'm going to take 210 and I'm going to divide by 1,000. So my final answer should be 0.21 grams. Okay, right? 210. Yeah. Miss Peterson isn't crazy. And that's my final answer. Okay. So some basic steps. You got to figure out which unit is larger or higher up on the scale. How many steps away are we? And then you can finalize your answer that way. Can I solve this another way as it's described on this stair step over here? Why, sure you can. But you do need to show your work. And so I'll talk about that other way briefly with this same problem over here. So if I started with 210 milligrams, I started over here with my milligrams, right? What's my starting point? I'm going to grams up top. This is going to be my ending point. According to my information, over here, as I move up the scale, I move my decimal place to the left. And I'm moving up the scale 1, 2, 3 steps, right? So I'm going to move my decimal place to the left 3 steps. My decimal place is hidden right now, so I just made it clear on my value. And if I move it 3 steps to the left, I go 1, 2, 3, and I place my new decimal place in there. And so that's the exact same answer I got as before, but doing decimal place movement. This is showing your work. physically dragging your line on your paper and showing me how many steps away each prefix is from each other counts as work. So if you like to do decimal movement, you already know it, you're comfortable with it, you can show me your work that way. But I highly, highly more encourage dimensional analysis process down below here, because this is what you use in chemistry and this is what you're going to use for more complex problems. So good luck with those problems. Please let me know if you have any questions.